dependencies, everything that it needs to run in one image. And then you can deploy that image to development, to staging, to production, whether it's Azure or AWS or Google Cloud or in a VM or anywhere that you want to deploy it. That image is unmodified, being deployed everywhere it goes. All you need to do is just modify the settings that go along with the image. Now, this is in contrast with traditional deployment, where you would compile an application with EXEs and DLLs and all of these things, but then you would need to do a number of steps to deploy that into various environments. There might be some packages that it relies on, like the .NET framework, or there might be some third-party software and DLLs that are required, and maybe even you need to flip a switch in the code to go between deployment and production and things like that. So traditionally, deploying code is a very manual process. You've compiled it, and then you go to deploy it. It could take hours. I can actually remember, going back several years before we had containers, that we would do deployments into production, and the deployment would start at midnight, and we hoped to be done by 6 o'clock in the morning, but oftentimes by 10 a.m., we were just finishing up. And so it was an 8 or 10-hour process to deploy complicated applications in production. Containers simplify this process. So it's really, the benefits are along the deployments. So within Microsoft Azure, you have a number of options to deploy containers. Now, perhaps the most famous and popular one is called Kubernetes. Now, Kubernetes started off as a Google standard, a Google piece of software. Google has released it, and now it's become the industry standard for running complex enterprise applications as containers. Fortunately for us, the AZ 104 course no longer has questions about Kubernetes. Microsoft has removed Kubernetes from the requirements. So we're not going to cover Kubernetes too much in this course, but I'll tell you a little bit about Kubernetes. One of its main features is that it runs in a cluster, and you can actually tell that by the icon, where there are more than one server. You at least have to have 2 servers or more to run a Kubernetes cluster, and there's an orchestrator, which is like the traffic cop who is controlling everything, and then you're running nodes on top of your clusters and pods on top of your nodes, and it's a really complicated environment, but yet it is, again, designed to be infinitely scalable at enterprise grade, things like that. So there's a special software called Kube Control, KUBCTL, that you use to control Kubernetes. And again, it's not for basic small cheap projects. It's a production version. Kubernetes is not the only container. We have a simplified one called container instances that is covered on the exam. These are typically single node instances, like you see in the icon. There's only a single instance that's running your software, but it's extremely simple to set up. You have to provide a link to the image when you're creating the instance. And in only a few seconds or a few minutes, you can have an instance running and no special software required and things like that. So container instances is sort of the other end of the scale. I often look at this as being great for demos, for small internal applications, something that does not require redundancy, does not require 5 nines of uptime. So container instances is obviously an option. In the last year or so, Microsoft has come out with a new service called Container Apps. And Container Apps provides some of the flexibility of web apps and the simplicity of container redundancy, does not require 5 nines of uptime. So container instances is obviously an option. In the last year or so, Microsoft has come out with a new service called Container Apps. And Container Apps provides some of the flexibility of web apps and the simplicity of container instances and some features from Kubernetes. So Container Apps is sort of trying to be in this middle between the complexity of a Kubernetes and the simplicity of an instance and some of those features, developer level features of a web app. And so we're going to talk about that in this course as well. Now, I should also mention that there are other technologies you may hear of called Service Fabric being one. This is not on the exam, but this does have a container option. Of course, you could create a virtual machine and create a container, install Docker and create a container on your own virtual machine. You'll be entirely responsible for deploying that. Containers on a virtual machine, not on the exam as well. And finally, I did mention web apps. Web apps does have a container option. So if you go under App Services and to create a new web app, you're given 2 options. Is the code, which is the traditional web app where you choose the underlying image, like the software that's going on. So if you want a .NET web app, you choose that here. And finally, you can have a container. Containers support both Linux and Windows options. But like I said, this is a very simple way if you create the container image on your own, you can deploy it into a web app, and you have all of the flexibilities, the scaling, the auto-scaling, the deployment slots, things that web apps provide, you can take advantage of as a container. So Azure is really providing lots of options. There's pros and cons for each of these. So in this course and in this section of the course, we're going to be talking about container instances and container apps and the scaling of those. And we'll talk about container registry as well as a related service. So stay tuned for that. So we talked at the beginning of this section about the types of containers within Azure, and one of them is called Azure Container Instances. Now, we saw this briefly when we were talking about scaling for AKS, that you could burst scale into a container instance, and that container instances were both cheaper and faster in terms of deployments. And so in this video, we're going to create Azure Container Instance, or abbreviated as ACI. We'll see how easy that is and the limitations of that. So Microsoft does like to tout that this is one of the fastest ways of deploying container apps without having to manage underlying virtual machines or having to use kube control or any of those things. It's just quick and simple to deploy a container image. Now, you could argue that Azure Web Apps with containers is not difficult either, but we'll compare and contrast those two. So let's start with container instances. We'll go into the create a resource, and we see that container instances is under containers. And I'm going to say create. And we do have to create a resource group. So I'll call this AZ container and give it a name. The name only has to be unique within the resource group. We have to deploy it to a location. So I'll deploy it to Canada Central. Now, it does support availability zones, but since you're only deploying one of them, you don't have the checkbox metaphor where you can deploy 2 or 3. So if I do deploy to an availability zone, it's just going to live in that one zone. There is the difference between standard ACI and a new trusted execution environment. We saw this on VMs where you could choose to deploy this trusted execution environment, and that was the default. But that is a region specific, and you can't choose it if it doesn't exist in this region. Now, that's pretty much it. We do have to choose the image. So we could have manually copied the mcr.microsoft.com URL here. We could have an Azure Container Registry of our own inside of Azure, or we could choose from a list of Quick Start. And we can see that in the Quick Start, the Hello World is one of them. So I don't have to paste in the URL. It's one of the options. We also have a Linux web server called Nginx and a Windows web server, which is a server core. So I'm going to deploy the Hello World app that we just saw for Kubernetes. Now, it's going to be a very small server, one virtual CPU, 1.5 gigabyte memory, but it's a Linux machine. It should not be a problem. We do have the choice between public access, private access, which is only for Linux and not for Windows, or no access, and you're going to have to add access in order to get people to do it. So we'll leave it as public access. Now we're going to have to come up with a DNS label. And so I'm going to call this AZ SGD app. Now it does actually create a scope for this. So I could choose, I can choose web app because it's going to hash my tenant and come up with a sort of a label to append to this. I'll leave that by default. I could turn that off or have a subscription level reuse or resource group. Tenants is fine. Port 80 is fine as well. I won't add the 443 port. How does the container get restarted on failure? It gets restarted always once it's stopped or never. I can mark it secure. I'll leave all of these with the defaults. So we'll skip over the tags and we'll say review and create. So this, obviously the interface was a lot simpler than Azure Kubernetes. Plus we've specified the image. We don't have to deploy an image into it. It's going to launch deployed. So I'm going to hit create. So we can quickly see how long did that take to deploy, operation details, and it took 41 seconds. So that's a very quick way to get an image live. I'm going to say go to resource. And like I said, it has taken my tenant, turned it into a unique string, and so I can have web app dot my tenant dot all of this. It says running. Now if I go under settings and under containers, I can see that the image was pulled, and that the image was started and the current state is running. So what I can do is open a new web browser here, and I can paste the URL into it, and boom, right? We have our container instance already loaded. The app, the Hello World app loaded as well. So that's as simple as it is to deploy an Azure Container Instance. Now, Azure Container Instances are great for when you need a quick deployment. You're not interested in complexity in terms of having multiple servers and pods and scale sets and all of these things, but there is limitations. So like I said, we do have our single container that's running right now, hasn't been restarted. Now there's not really any settings to speak of. If we go under containers, we see you have the container, but it's not even clickable. There's no properties here, nothing that you can change in this Azure portal. And that's sort of one of the downsides is there's no scaling involved, right? So it's not like you're going to be able to scale up and scale down and scale out. It could be public if you want, but really it's limited. And that's why people use this in conjunction with an AKS instance, where if you need to scale, it'll create you a container instance. But that's the AKS is what handles the scaling. It'll create it and it'll destroy it when it's no longer needed and things like that. So Azure Container Instance, as we saw, extremely simple, limited, quick, and one of the easiest ways to deploy a container image live for testing, demonstration, very simplistic purposes. So I just wanted to create this quick video to talk about scaling for Azure Container Instances. The requirements for this exam says configure sizing and scaling for Azure Container Instances. Now, there's only a couple of ways that you can work with scaling within Azure Container Instances. As I said in the previous video, when you create the instance, that's it. It's a single running instance. You have no control over the hardware. And when you go into the Azure Container Instance overview on the portal, there's no auto scale, there's no manual scale, there's no way to modify what's running. So in order to actually change the size and the amount of resources available to a container, you effectively have to redeploy the image to a new Azure Container Instance. As you can see, when you create an ACI, you have this option for size, and it says change size. You have the number of CPU cores that you can choose between 1 and 4, and you have memory you can choose between 1 and 16. Again, this cannot be modified once you have launched this ACI. And so one option is to launch a new ACI. If you needed to go from 1 and 1.5 to 2 and 3, you launch a brand new ACI, and then you can eliminate the old one. And if you have this running behind some kind of load balancer or something like that, then you don't have to change the public IP address. It's a really manual process, and obviously you've got to script this, and it's a little bit of effort. What Microsoft does want you to do is use something like AKS, the Kubernetes service that has the orchestrator. Now, we've talked previously in this course about burstable scaling into Azure Container Instances. And so if you enable that option, then what you get is what's called a virtual kubelet. It's very similar to the kubelet, the kube control application that you can control your ACI using that, and again, inside of AKS scaling. So you have some more control. The other option is container groups, and then you could have multiple containers running inside the group, etc. So standalone ACI instances, you really don't have any automated or manual options for scaling other than redeploying the container. If you use some kind of orchestration method like AKS, then obviously you have other options. If you did everything manually, you had your containers running behind a load balancer, you can add and remove containers in a horizontal scaling method as you wish as well. So scaling within Azure Container Instances is not easy, still doable. Better to use a more complicated solution like Container Apps or AKS. So in this video, we're going to talk about container groups. Container groups are a collection of containers that are basically running in the same host. So you can imagine you have a Azure Container Instance, and it has more than one container running in that set. It has one app name, a public IP address with the DNS name, and that means that if they're running on the same host, then they would have to have different ports. And so you can have two apps running in the same host. That makes it very convenient for them to talk to each other. You can have one that's private, one that's public. There's a lot of advantages to having. This is very analogous to pods, the concept of pods within the AKS environment. So for ACI, you can have container groups. Now, the problem that we will have is that you can't create container groups in the Azure portal. It must be created within the command line. So we're going to go into a bash CLI right now. I'm going to pull this up, and we're going to deploy a couple of test images into a container group. Now we're going to use a code editor. Remember, I said before, there is 3 of them. You can have VI, you can have Nano, or you can have code. And we're going to create a new file called azuredeploy.json. This is a typical code editor view. Now I am copying this code. I will put a link to this in the attachment, the resource for this video. All right. So it is an ARM template. I'm going to basically shift insert to paste the code in there. And we'll take a look at this. So this is a typical ARM template. And it has 2 containers. One is ACI, a tutorial app, which is the ACI Hello World that we've been dealing with. And then there's also a sidecar app. And so what it's doing is creating a resource called container instance / container groups. And we are passing in as properties the 2 containers. One is the tutorial, the Hello World container, and it's got port 80 and port 8080 open. And the second one is the sidecar. And you'll see there's no ports that are being requested for the sidecar. It's running in a Linux container, and it's going to have a public IP address. All right. There is one single parameter, but it does have a default. So that's fine as well. So I'm going to right-click this and say save, and right-click it and say quit. So now we have a deployment file, and we have to do a couple of things in order to deploy it. First thing we want to do is create a resource group. So AZ group create. We give it a name. It's going to be my.rg, and we give it a location, East US. All right, so we have a brand new resource group, my.rg. And next we got to do is do AZ deployment group create. And that's going to deploy this JSON file that we just created into the resource group we just created. So I can say resource group, my.rg, and template file is Azure deploy.json, or whatever you named that file. So this is going to deploy those 2 sample images into 2 ACI instances running inside of a resource group, running inside of a container group. So we'll let that run. So we have a successful deployment according to the output. Let's clear this. There's a couple of ways to look at this. We can use the AZ container show command and choose my RG resource group and my container group as the group. And we can see that my container group is running, and it tells you which images are there, the IP address that's available. The other way we can look at this, of course, is to, I'm going to pull this down a little bit, go into resource groups of the portal. We can see my RG is there. We can see my container group is a container instance, plural. And now we can go inside of here and we can look at, on the containers tab, we can see there are 2 containers in this container instance and they're both running. If we really wanted to, we could go to the public IP address and we can get the demo image. Unfortunately, we can't load the sidecar app because it's not exposed publicly, of course. But in this way, we've created a container group, which is a set of containers running in the same host. So in this lesson, we're going to dive into Azure Container Apps. This is a relatively newer service. It popped up around 2022 and made its way onto the AZ 104 exam shortly after. You could think of container apps as the Goldilocks solution for running containers in Azure. On one hand, you have Azure Container Instances, which are super simple and lack advanced features. On the other hand, you have the Azure Kubernetes service, which is incredibly powerful, but comes with a ton of complexity, managing nodes, clusters, and all that stuff. So Azure Container Apps sits right in the middle. It gives you serverless containers with some of that Kubernetes power, like scalability and load balancing, without the headache of managing the underlying infrastructure. So let's jump into the portal and see how to deploy one. So if you're coming from the portal dashboard, you can simply type container apps in the search bar, or you can go into all services under containers and you'll see container apps there as well. So I'm going to click the container app create button. Now, first we're on the basics tab, and we've all seen this before. We need to pick the appropriate subscription for this and pick the appropriate resource group. And we have to give the app a name. So I'll call this Azure Container, one word. Now you'll notice that you could deploy an Azure function developed externally and packaged as an image into this container app. We're not going to address that right now. We are going to deploy this as a container image. And so either you bring your own container registry or you build it from a Docker on your own system and deploy it as an image. You have the option of deploying the source code. And so this introduces a new source code tab where we can say where the image is going to come from. So let's just deploy this traditionally as an image. So the first concept we're going to really deal with here is this concept of the environment. So this is like a secure boundary for your container app. So you can create an environment and deploy multiple container apps into the same environment. So I'm going to create a new environment. I'm going to click the create a new environment button. Now, you'll notice that I chose a region on the previous tab there. We do have to give the environment a name or just accept the name that it's giving to us. Now, we also have options for zone redundancy if we want this to be in the high availability category. You'll recall talking about virtual machines, we talked about zones. This adds to the redundancy and increases the high availability of the solution. So if I need that, I can click zone redundancy. Next up, we can identify whether we want to have customized hardware. So if we know that we have a specific workload that we're running on here, then we can create a new workload profile. The default that we're being offered is a consumption profile, and the environment always has one available where it's basically scaling up to 4 CPUs, 8 gigabytes of memory, and it allows you to scale to 0 and pay for only resources you use, a typical consumption workload. Monitoring tab, we're going to see the traditional log analytics options. So if we want the container app to log its usage and be able to manage performance through log analytics, then that's available. We can send it directly to Azure Monitor, and that will be a traditional diagnostic settings. Or we can say we don't want logs saved anywhere. They'll be streamed, but not saved. We can certainly choose that for this demo. And do we want this container app to be available to the internet? I do. Do we want to deploy it to a virtual network? And I don't, right? This is the traditional public internet, deploy it specifically to a network or even using private endpoints. So now I'm going to create for the environment. So now on the basics tab, everything looks good. We have a brand new environment being created. We're going to deploy to this region. Next, I'm going to say container. Now this is where I identify the image that I want to use. In this case, I will use a quick start image, but if I have an Azure Container Registry, I can choose from that and deploy an image that I've created or a public Docker Hub image. Let's pick one of the simple Hello World containers. You'll notice that this Hello World is asking to reserve a quarter of a CPU and half a gig of memory. And remember, when we created the work profile in the environment, we had a much larger 4 CPUs and I believe it was 8 gigabytes of memory. So we are using only a fraction of the memory that we have available to us on this workload profile. So this means we can deploy a number of these container apps to the same environment because they're only using a fraction of the available space. Now, since I want this to be publicly accessible, we have ingress settings, and those are set to enabled. We want to accept external HTTP traffic over port 80. Now, we don't need to define any tags for this, and I'm going to click Review and Create for it to validate. So the validation passed, and I can click Create. And that'll take a minute or two to create. And that was pretty quick. Let's look at how quick that did take. If I go under Operation Details for the app, 3 minutes. So we're going to click on Go to Resource. And we're in the Container App Overview. Now you'll see the application URL on the screen. I'm going to say Copy to Clipboard to get that URL. And if I paste that URL into a browser, it says your container app is running with the Hello World image. So that was successfully deployed. So now let's go back to the portal and look at the container app in the portal. Let's see what makes this different compared to an Azure Container Instance. Under the application menu, we can click on Revisions, and we can see the details of what was deployed to the container app. Container app supports multiple revisions of your app running at the same time. So whereas we can use deployment slots, in web apps, we can use revisions to have multiple versions running and have traffic diverted on an A/B test between them. If I go to the left and click on Scale, I can see the rule is min replicas 0, max replicas 10 in this particular setup. So it'll automatically scale between 0 and 10 instances based on the demand. We can see that there's already been an HTTP scaler that's been added to it. But if I wanted to set up my own scale rules, I can add the scale rules here. So unlike the ACI, this can scale, and it can scale based on the HTTP traffic or even triggers such as the number of messages in a queue. That is basically what they call KEDA, K-E-D-A, Kubernetes Event-Driven Autoscaling. But you don't have to configure anything Kubernetes related to use it. You get these scaling options as part of a container app. So let's recap. The Azure Container Apps gives you serverless, scalable container platform that's enterprise grade, but also developer friendly. You get features such as auto-scaling, ingress management, and DAPR integration without ever touching a Kubernetes cluster configuration. So we saw when we were creating the container instances and the container apps that we had the option of pulling the image from a registry that we control as opposed to the sample image. And that would be one example of that would be the Azure Container Registry. So Azure Container Registry is basically a private container that lives in Azure that you can store your images. It's like a code repository, but you're not storing code, you're storing images for your containers. It supports versioning, it supports types of security, granting access to certain people to it. Again, this is a private repository. You have the choice of setting the particular level of privacy that you want on your images. It allows you to have tasks that do automated builds and automated deployments. Once you push something into the registry, it can actually cut off some tasks. So I'm here to create a container registry. I'm putting it in my resource group. I'm giving it a name, giving it a location. Container registry does support availability zones, which means that it gives you an additional layer of availability. If one particular data center in a region is down, if you've deployed this into several zones, you would have a redundancy. That's only available on the premium plan. We have basic, standard, and premium options. We can see from the Microsoft Learn website, basic is more like a developer option. It comes with a low amount of storage, and it's really for lower usage scenarios. Standard is the same as basic, except it has higher amount of storage and can pass through more images in terms of its bandwidth. It should satisfy most production scenarios. And the premium registry has the highest amount of storage, highest amount of concurrent operations, and it also has geo-replication so that you can have a single registry across multiple regions. And you can even use private links so that it doesn't even have a public URL. You have to set up this point-to-point connection to restrict access to the registry. And as we saw, then you can use the availability zones as well. So for the purpose of this demo, I might as well just pick a basic registry. Now, in order to get this as a proxy onto a network where I can have private access versus public access, I do need to be on the premium SKU. Content, customer managed keys, only available on the premium SKU. And then I can say review and create. So like I said, this is just like a container. There's a certain amount of storage. It can handle a certain amount of transactions per second, etc. And so, but it's tied towards images, container images. So I'm going to say go to resource. So on the basics here, you can see I have 10 gigabytes to work with, obviously a low amount that would be restrictive if I wasn't only just doing this for development. So in the next video, I'm going to show you actually how I will push an image into the repository and pull an image out of the repository as a demonstration of what a container registry can do. So let's create a sample app that we can then deploy to the container registry. So what I'm going to do, I'm in Visual Studio 2022, and I'm going to create a new project. Now, there's many ways to get images. You could obviously download from one of the public repositories an image to your local. I'm just going to create a new app in Visual Studio 2022, .NET Core Web App. And I'm going to call this Docker Sample App. Now, remember that on Windows Home Edition, you can't run Windows containers. You have to be the Professional or Enterprise Edition in order to do that. So I've chosen Linux as the operating system, and it says Enable Docker. So these two elements are the key for this particular screen. I'm running on .NET 7, which is a later version of .NET. I'm going to say create. I do have Docker running. The Docker engine is currently running. I have a Windows subsystem for Linux 2 installed and running. So all of the prerequisites are there. And now I have this sample Docker app. You can see in the debug toolbar, this says next to the green play button, it says Docker. So if I go to run this, it's going to try to run it inside a Docker container. In the container tools output, I can see verified that it's running. Docker desktop is running. Verifying it's Linux. It does match Linux. It's pulling in the missing Docker image. So I don't have .NET 7 Docker image. So it's downloading that and it's ready. Everything seems to be ready. So if I wanted to, I could run this in a debug mode locally, and this will compile the application, turn it into an image, and put it into a container on my local machine. Now it says finished. So let's do that. I'm going to say go. So it's going to try to build this sample app. I made no modifications to it. And it's basically going to create this as a DLL. And now it's going to create this as a Docker image. And so it is running. It says welcome. And it's running under my local host. So this is a Docker container that has a web listener. And so running against this port inside of Docker on my local. In a command prompt, I can say Docker container ls, and I can see that my Docker sample app is running in a container on my local. I can even see the port number 32768. Great. So right now we've proven that we've got this is a Docker image, but this is not exactly what we wanted to do. What we want to do is we want to push this into the container registry. So under build, I'm going to choose publish. Now I've never published this before. And so I'm publishing this to Azure. It does say Docker Container Registry, but that is obviously a third-party container registry, and we're talking about Azure here. So I choose Azure as a target, and I could deploy directly to an Azure Container App or an Azure App Service, but I want to publish to the Azure Container Registry. So I say next. Now I do have to log in. So you can see here, we did not find subscription. I do have to choose my subscription. I'm going to validate my credentials here. All right, so it's able to recognize my account, my subscription now, and I can find the Azure Container Registry that we created and select how to build and push the container. So I can create the container using .NET, or I could build the container using Docker Desktop. Now I do need to have a Docker file. You can see there is a Docker file. So I'll just do that. Actually, at this point, it's just created the profile. So I'm going to say close, build the app here. You can see it's calling Docker behind the scenes to rebuild it. Now it's completed the build, and now it's starting to publish. And what we're going to see here is it's going to be uploading these files into this container registry at this URL. You can see it's pushing. That's a good sign. Finally, it succeeded. So apparently this is now sitting in my Azure Container Registry. So I can go into my Azure Container Registry. I can go down under services and see repositories. Haha, unauthorized. So this has been happening to people. What we have to do is specifically give ourselves reader access to this repository, or in this case, owner, I guess. Go into access control, add role assignment. I'm going to give myself reader access, selected my own account, and I'm going to say review and assign. All right, so if I go back to repositories, I can see the Docker sample app. And we just deployed one version, so it's the latest tagged version. So now we have an app in our repository. In this video, we're going to pull a public image from the Docker Hub, and we're going to push it into our private Azure repository. So we're going to do a Docker pull and followed by a Docker push. Before we do that, I'm running this in my PowerShell on my local. So before we can connect, we need to connect to Azure and then connect to the container registry. So I'm going to say connect AZ account from my local here. You don't have to do this from the Cloud Shell. And then I have to log in. Authentication complete here. Now I have more than one Azure subscription, so I do have to set my context. So get AZ subscription to get a list of them. And then I'm going to say set AZ context with the subscription that I'm interested in here. All right. So I do have to connect to the container registry as well as being connected to Azure. So it's connect-AZ container registry and just the name of the registry. Azure is going to fully qualify this for us. It'll say login succeeded. Now, if it doesn't, sometimes you do have to allow yourself what's called admin user access. So this checkbox on the access keys if this doesn't work. So now we're logged into Azure. We're logged into the Azure container registry. So just to be safe, let's use the Docker login command in order to authenticate Docker application with the Azure repository. And that says login succeeded. Now we're going to go back to effectively what is Docker and say Docker pull. And we're going to get the Nginx. It's a very small web browser client. So web server, I mean. So Docker pull Nginx. And you can see it's going to a public registry to download the latest Nginx server. All right. So that pulled into my local. Now, one thing we can do is we can run it. So we can use the Docker run command. And we can basically give the parameters to say we want interactiveness, IT, on port. And we're going to use port 8080, mapping to port 80 within the container. And we're going to start the Nginx image locally. So this is going to start up a little web server on my machine. In order to see that this is running, I'm going to have to go into localhost, and it's on port 8080. So now we have Nginx responding to our little Docker server. So we know that it worked. We pulled the correct image. I'm going to say Control-C to stop the server from running. All right. Now we're going to use the Docker tag command. And what this is going to do, it's going to add an alias. So we have this local Nginx repository, and we're going to add to, in your case, it's going to be different, but my azsjd demo.azurecr.io, and we're going to call this Nginx. And what this is going to do is it's going to say this repository has basically a alternate location. It's called the tagging and namespace. All right, now that the image has been tagged with the remote server name, you can now say Docker push with that same server name with azsjd demo.azurecr.io/sample/nginx. I can say push. And it's now pushing. You can see the work being done. And the image has been apparently pushed, and it's giving me the SHA-256. If I go back to Azure Container Registry under repositories, drum roll, there's the samples/Nginx repository that we just pushed using PowerShell.